Prepare to be blown away by this mind-blowing ZIMSEC Physics Practical Paper 3 of Year 2022 video. In just a few minutes, you'll grasp the secrets of Ohm's law and Archimedes' principle. Brace yourselves, because your understanding of physics is about to reach new heights.
Setup as shown in Figure 1.1a. Add 100 gram mass and record force meter reading. Add 200 gram mass and record force meter reading. Add 300 gram mass and record force meter reading. Add 400 gram mass and record force meter reading. Add 500 gram mass and record force meter reading. Add 600 gram mass and record force meter reading. Let's proceed to Figure 1.1b.
That's water being poured.
Repeat, but with masses submerged in water. That is a micrometer screw gauge. Constantan wire. Fasten the wire and record the reading. Setting up apparatus as shown in Figure 2.1. Adjust length on ruler to 90 centimeters and turn on switch.
Record voltmeter and ammeter readings. Adjust length L on ruler to 80 centimeters and close switch.
Read and record voltmeter and ammeter readings.
Adjust L to 70 centimeters. Close the switch.
Read and record voltmeter and ammeter readings.
Adjust L to 60 centimeters. Close the switch.
Read and record voltmeter and ammeter readings. Adjust L to 50 centimeters.
Close the switch.
Read and record voltmeter and ammeter readings.
Adjust L to 40 centimeters, which is the last one. Close the switch.
Read and record voltmeter and ammeter readings.
Let's now attempt the questions. To complete this table, you would need to obtain values from the experiment which I did, so I will just reproduce them here. M is representing mass and U representing difference weight from the table. It might be advisable to pause the video and follow up. A smaller part will be shown, then the rest later. As you can see, the line of best fit attempted to divide the points in such a way that half of the points are above the line and half below the line. Pause the video and follow the steps. H is the gradient. Let's go on a physics journey together. Units of gradient. In the equation U equal to hm, h represents the constant of proportionality between the difference in weight and mass. Its significance lies in indicating how much the weight difference changes per unit of mass. A larger h suggests a greater buoyant effect of water on the object being measured, reflecting the object's density relative to water. Instrumental errors, a faulty or poorly calibrated force meter, or parallax errors in recording, could also provide incorrect readings. Equipment limitations. The accuracy and precision of the equipment used may not be sufficient to detect small changes or differences. These sources of error could be minimized by repeating the experiment, using multiple measurements, and ensuring careful attention to detail in the experimental procedure. You may have to pause and follow the steps. Here you had to be careful about the decimal places. You might want to take a moment and freeze the video to focus on the intricate details. For average length, add lengths from the table and divide by 6. To obtain the average, sum up all the resistance values in table 2.1 and then divide by 6. To obtain rho, you need to start by converting. You may need to pause the video and follow through. You may need to pause and follow the steps. Poor connections at the terminals or solder joints can add extra resistance, affecting the measurements of current and voltage. Lastly, variability in wire diameter, composition, or other characteristics can affect resistance. When you're filling in the table, remember to include the units. If they're missing, be sure to write them in. Make sure you write the results to the correct number of decimal places or significant figures. In this case, the weight should be written to 1 decimal place, along with the difference. If not, don't forget to state the units. When conducting the experiment, it's important to understand the background so that you can interpret the results accurately. In this situation, Archimedes' principle is at play, where the buoyant force of the water reduces the weight. It's expected that the results in water will be lower than in air. If you obtain different results, you may need to redo or re-evaluate the setup. Do you want to know the secrets to gain 4 marks on question 4C, construction of a graph? Buckle up. I'll spill the tea. Give yourself 1 mark for simply slaying the labels on the X and Y axis. Another mark awaits you for creating a graph so big, it occupies more than half of that graph paper grid. Almost there. Don't just plot 1 or 2, but all the points to impress the examiner. Finally, serve them the pièce de résistance, a flawless line of best fit for that last mark. Dreamy, isn't it? For question 2A, where measurement is demanded with a micrometer screw gauge, take the following tip. Not once, not twice, but thrice must you measure the Constantine wire, exploring different parts of the Constantine wire, before calculating the average. Beware the perils of singular judgment, for it's bound to give inaccurate results. When using the micrometer screw gauge, all you need to do is understand the main scale and the vernier scale. The main scale, located on the micrometer barrel, measures in millimeters. Simply read the whole number value on the main scale. The vernier scale, found on the micrometer thimble, measures in fractions of the main scale unit, usually 0.01 millimeters. To read the vernier scale, align the lines on the vernier scale with the lines on the main scale. To obtain the final measurement, combine the reading from the main scale and the vernier scale. In our situation, the main scale is 0 mm, vernier scale is 0.19 mm because it aligned to the main scale. Final reading is obtained by adding main scale 0 mm and vernier scale 0.19 mm to give 0.19 mm. Bear in mind to always handle the micrometer with caution and capture multiple readings for precise results. Electricity is a form of energy that can be carried by wires and is used for heating and lighting, and to provide power for machines. In this experiment, the electricity was sourced from batteries. Electrons travel in zigzag patterns through wires or other external circuits, which results in a collision between the electrons and the ions in the conductor, and this process is known as resistance. This experiment looked at how it could be controlled. There are 4 factors of a wire that impact on the resistance of a wire: material, temperature, diameter, and length. This experiment focused specifically on the last factor, length, to investigate how much the length of a wire affected its electrical resistance, using a range of wire lengths to test with. For this experiment, the only independent variable was the length of the wire. The results in the table represent a nearly straight line, indicating a strong positive correlation between length and resistance, which is consistent with the prediction of Ohm. Overall, the results were consistent with the predictions. There was one reading that veered away from the straight line, but all others were consistent with the general trend. A kink in the wire could have led to this inconsistent reading, as it would have prevented a particular part of the wire remaining constant, therefore skewing the result. Did this mind-blowing video leave you wanting more? Then give it a big thumbs up and smash that subscribe button for an electrifying dose of ZIMSEC Physics Practicals and other mind-blowing science experiment. Let's explore the unknown together. Remember, I'm always on the lookout for mind-blowing topics to unravel. If there's anything ZIMSEC Practical related you're dying to see in a video, shout it out in the comment. Thanks again for joining the mind-blowing adventure. Prepare yourself for more mind-expanding content in the future.